Hi, I'm Ian Keller. This is a short video giving some context as to the development and update of systematic review automation tools and to introduce a tool called Rayyan. So we're going to be looking at classifiers today, and that's something that has been looked at by XKCD. So where are we in terms of the course? Well, we're still in the week 5 to 7 block where we're retrieving, managing and screening papers to fulfill PRISMA. And you're in that part of the learning objectives where you're learning to retrieve, manage and screen references and full text in a database. So what do you need to have done? There's the week 3 do list. I won't go over that again, but it's important that you are recording your search and screening strategies, and that you have undertaken your searches, and that you should now have deduplicated your searches and split them by pairs using a method I showed you last week, and named those text files that contain the Endnote export by screening pair so that you can identify them. If you haven't done that already, watch last week's video as far as 29 minutes and 7 seconds. 5 core activity tasks are the key parts of systematic review: planning and preparing a review, retrieving the relevant evidence in the literature, evaluating risk of bias in selected trials, synthesizing the evidence, and reporting the systematic review. And technology may support speed or accuracy in each of these steps. Until relatively recently, estimates as to the time taken to undertake a systematic review have been daunting. A survey of rapid reviews undertaken in 2008 by Watt et al. Found that even rapid reviews can take 6 months, and a 2017 study by Bohr et al. The resources needed to conduct systematic reviews of medical interventions using data from the Prospero registry was over 67 weeks, with an average of 5 authors working on the review. On average, less than 3% of the studies retrieved were included, and this demonstrates the potential need for support if timely reviews are to be produced efficiently. So how can automation support systematic reviews? A review from 2019 suggested it offers ways forward in reducing the amount of time systematic reviews takes. And this could include automatic identification of concepts and related documents, thereby reducing the amount of time searching, filtering and categorizing relevant documents, and supporting reviewers in the description of research identified using automatic text summarization. By applying these technologies with human involvement means that we might move away from identifying every relevant paper by hand to identifying perhaps a proportion of the relevant papers, but from a much wider base. So where are we now? The 2019 meeting of the International Collaboration for the Automation of Systematic Reviews identified 3 main themes from the meeting of 50 researchers that attended. The available set of tools is growing. Creating linked up workflows with the available tools and future tools remains an unsolved issue, and there is a problem of interoperability. And lastly, there is a need to focus on developing approaches to gaining acceptance for tools. On point 1, a narrative review by Marshall and Wallace in 2019 categorized the function of automation tools in systematic reviews as search, screening, data extraction and synthesis. And a systematic review of 41 studies by Van Dintner et al. On the use of automation in systematic reviews used a 2007 taxonomy. All applications of automation in systematic reviews were in items SLR 5 to 9 on screen now. So literature searching, citation screening, data extraction and synthesis. They identified that the most commonly automated step was SLR 6, citation screening, followed by literature searching SLR 5 with its substep formulating the search query being the only automated. The least studies were about study quality assessment, SLR 7, and powerful search queries take a substantial time to iterate. So as a result, systematic reviews can take months to complete, and in the case of a couple that I've been on, £250,000 a pop. Van Dintner et al. Conclude that the screening phase attributes most of these costs, where there are typically many false positives, so low precision, causing a significant impact on the time spent in the study. A significant impact on both the total cost of review and the time required to produce a review can be achieved with even small increases in precision. So how does this technology operate? First, a training set of documents is obtained through hand searching or prior knowledge. This set will be manually categorized, e.g. as an included study or an excluded study. Next, the text is transformed into a numerical representation of the text or vectorized. A simple common representation is known as a bag of words, where a matrix is constructed in which rows are documents and each column corresponds to a unique word. Documents may then be represented in rows by noughts and ones, indicating the presence or absence of each word or phrase. The resultant matrix will be sparse, i.e. will mostly contain of noughts and relatively few ones, as any individual document will contain a small fraction of the full vocabulary. And in the case of Rayyan, this is the process that we do when we create the initial training set, where we maybe calibrate against other researchers. Next, weights or coefficients for each words are learned or estimated from the training set. Intuitively, for this task, we want to learn which words make a document more or less likely to be, say, a randomized control trial. Words which lower the likelihood of being an RCT should have a negative weight, and those that increase the likelihood, such as random or randomly, would have positive weights. As such, the model coefficients correspond to the parameters of a logistic regression model. Once coefficients are learned, they can be applied to a new unlabeled document to predict the label. The new document is vectorized in identical way to the training documents. The document vector is then multiplied by the previously learned coefficients and transformed into a probability via a logistic regression process. In all of the available systems, human reviewers first need to screen a set of abstract and then review the system recommendations. Such systems are thus semi-automatic and keep humans in a loop. The typical workflow is shown there for semi-automated abstract screening. And the asterisk indicates that with uncertainty sampling, the articles which are predicted with certainty are presented first. This aims to improve the model accuracy more efficiently. So you get to make decisions on the ones that are more likely to be included early on. A key limitation of automated abstract screening is it's not clear at which point it's safe for the reviewer to stop manual screening. This point will vary across reviews, not just across platforms. Screening systems tend to rank articles by likelihood of relevance rather than providing definitive dichotomized classifications. However, even low-ranking articles have some probability greater of 0 than being relevant. So there remains the possibility of missing a relevant article by stopping too early. Empirical studies have found the optimal stopping point can vary substantially between different reviews, even when working on the same screening platform. Unfortunately, the optimal stopping point can only be determined definitively in retrospect by looking through all the full texts. Helpfully, Wallace and Marshall provide an overview of some of the tools available. The tool we'll be using is Rayyan, a free web app. This helps speed up the initial screening of abstracts and titles using human in a loop screening. A survey of beta users in 2016 highlighted the ease in exploration of searches, the time saved, and simplicity in sharing and comparing include-exclude decisions. The strongest features of the app identified and reported in user feedback was its ability to help screening and collaboration, as well as the time savings it affords to users. It uses the same processes shown previously, but more specifically, after removing stop words and stemming the remaining words from title and abstracts, Rayyan extracts all the words and pairs of words and previously computed mesh terms. These are then used as features by a support vector machine classifier. As users label citations to studies as included or excluded, Rayyan calls the SVM classifier, which then learns the features of these excluded and included citations and builds a model or classifier accordingly. The classifier then runs on the citations that await, labeling and outputs a score for each of these on how closely each study matches the include-exclude classes. That score is then just turned into a 5-star rating, which is presented to the user. And as the user continues to label more citations, if Rayyan believes it can improve the prediction quality, it will then use these new labeled examples to produce a new model and then run on the remaining non-labeled citations. This process is repeated until there are no more citations to label or the model can't be improved any further. So in terms of using Rayyan, the steps are relatively straightforward. Assuming you've watched the previous videos and have deduplicated the records, and you've re-imported the deduplicated records into Endnote Desktop, yep, this does require Endnote Desktop. And lastly, you've split the group equally between pairs of screeners in your group in Endnote as per the last video, remembering that if you have an odd number of screeners, get the odd person to do the dispute resolution. So if you haven't done those previous steps, go and watch session 5 video as far as 2907. Now, you have to do something slightly different. You have to export in the output style of Endnote export. And I found that I had to go into the output styles and find that. That took a little while. When Endnote first opens up the output styles, sometimes it could take a little while to search through all the output styles to find Endnote export, but it will be there. When you export the file, as per the settings displayed on screen, when you give it a file name, I suggest you name it after the pair of people that are going to do the screening of that file. Assuming you've already separated out your deduplicated references into groups, where you have a group for each pair of screeners, to get your references out of Endnote into Rayyan, go into the folder that has, say, one pair of records, and you're going to highlight all of the records within that pairs folder. And then you go to File, Export, and make sure the save file type is set to text only. Make sure that the output style is set to Endnote Export, and make sure the box next to Export Selected References is checked, so that once we've downloaded all of our pairs of citation files, we're ready to import them into Rayyan. If you're collaborating with a team of reviewers, and all of the people on my module will be, then only one person needs to complete this step. So there is a kind of a review owner who's going to kind of set this all up, and one of you needs to do that. Okay, so you're going to go to Rayyan.ai, and if you're a lead student, make sure you log in with or register with your lead's address. And then you're going to, the one person who's going to be the review owner, they're going to need to click New Review and give the review a title. And then you have to select options. And I think this changes some of the presets, but I'm not sure because I've only done it one way. I think this changes some of the presets, but I'm not sure. They don't matter because everything important can be changed later. I selected medicine and human health as a field. Review type was systematic review. And lastly, the review domain was biomedical. Once you've started the review, then upload the records for each pair one after the other. You're going to be asked to select a file, and you need to upload each pair's Endnote export file. And then you will see each pair's records underneath the heading Search Methods on the left-hand toolbar. Before any pair starts screening, they need to make sure they've clicked the correct pair under Search Methods that relates to them. So assuming you're the creator of the Rayyan review for your team, you now need to invite people to your review. You need to click on the All Reviews button on the top right, and it returns you to the overview screen. From there, click on your review and you can invite people, and you'll be prompted to give them a role. You need to select collaborator for each of them. The first stage of the screening process is typically a title and abstract screening process. Click on the review title and click Show to get to the main screening interface. The panel on the left of the screening page has the general information about your review. Rayyan tries to make decisions on topics and keywords to assist with inclusion, exclusion decisions. The main top center part of the screen lists the articles that you've uploaded and got selected. And to make a decision on a particular article, select the article from the list, and then the panel below the list of references in the bottom center will display citation information relating to that article, including the abstract if it's available. Use the include, exclude buttons as appropriate. If you are not sure about a particular article, you can use the maybe button, but I don't recommend this. It's much better to be inclusive at this stage and include things you're not sure about and look at them at full text again if you can't make up your mind based on the abstract. So let's assume from previous weeks you've already got really robust inclusion and exclusion criteria and you've decided you're going to start screening your articles. Rayyan offers a simple keyboard shortcut that you can use instead of clicking the buttons with your mouse. So you can click the key I to include, E to exclude, or U to mark the article as undecided. To make a decision on a particular article, select it, then use one of the keyboard shortcuts. It is possible to change your decision from include to exclude, but it's not possible to reset the article and remove its screen status once a decision has been made. In terms of making those decisions, you should re-watch the beginning of last week's session and remind yourself what your clear exclusion criteria are. At this stage, you should be excluding because you are clear that you know from the title and abstract that there is no way the study would be included. After reading the abstract closely, if you're still unsure, include it so you can look at it again and retrieve the full text and look in the methods of the paper when you have the full text to be sure. Now, I'm sorry, I can see on my screen that where I'm using chroma key to have the side here all see-through, it's meant that the green on the Rayyan interface has gone black. So just know that when you're looking at my screen over here, that and you can see my fingers poking through the holes, those holes aren't meant to be there, it's meant to be green. So this is where automation that I've discussed previously comes in. I should say this step is optional. You can just use Rayyan as a means of screening the entire set of records manually. However, if you want to use the Rayyan rating system to prioritize screening, after you have made 50 decisions, it's possible to click the compute rating button in the kind of mid-right, and then you will get a rating. Rayyan has an AI-powered 5-star relevance ranking system, as I've mentioned, which helps reviewers accelerate their systematic reviews by learning patterns in the decision criteria that the reviewers make and uses those decisions to rate the probability that an article will be included. So follow these steps. Make at least 50 inclusion and/or exclusion decisions in your systematic review with at least 5 of both type included and excluded. Then click compute ratings and you will see the message new ratings are being calculated whilst the AI engine calculates the likelihood of each article being included in your review, with 5 stars being most likely and no, I don't know if it goes to no stars, I'm not sure. Certainly it goes down in half-star steps. Once it's finished, you'll get the message, new ratings available. You'll also see star ratings in the ratings column on the right, ranging from 0 to 5 stars, a very high likelihood of inclusion. Please note that all decided references by any collaborator at the time of rating computation won't have ratings. In other words, if you click exclude on a paper, it will not have a rating for the other person in the pair. Step 3, now sort your review by least or most likely to be included by clicking on the sorting arrow beside the column name. When sorting on the 5-star rating system, the order is precise. In other words, the exact calculation dictates the order, while the visible stars show an approximation. As you make more decisions, you can compute rating at any time. The more decisions you make, the more accurate the ratings will be, as Rayyan learns more from each decision. So you can see from this that there are several ways that you can screen using Rayyan. You can do assessment of each record by single reviewer, which you could each screen, say, a third each or a sixth each, and that would be a highly efficient use of time, but there is a much higher risk of missing relevant studies. I can't remember the reference off the top of my head, but I think compared to, for a fully known review, I think it's about 10% get missed by single screeners versus 3% by double screeners. But these numbers are, will vary by review. Double screening can vary from checking of all records or doing them independently, or checking a sample only, for example, a random sample of screen records or all excluded records. And this approach may be more reliable than single screening, but at the expense of increased reviewer time, given the need to resolve discrepancies. Priority screening, which is what I've just described there, where you're prioritizing by potential relevance, is where you focus the early screening on the most relevant records. Instead of screening records in order of year, title, or author, or random order, machine learning is used to identify relevant studies earlier in the screening process than would otherwise be the case. And priority screening is an iterative process where the machine continually reassesses unscreened records for relevance. And this approach can increase review efficiency by enabling the review team to start on subsequent steps on the review while less relevant records are still being screened. Both single and multiple reviewer assessments can be combined with priority screening. And then the last type, priority screening with automatic elimination of less relevant records. Once the most relevant records have been identified using priority screening, the team might choose to stop screening based on the assumption that the remaining records are unlikely to be relevant. However, there is a risk of erroneously excluding relevant studies because of uncertainty about the safe point to stop screening. The balance between efficacy gains and risk tolerance will be review specific. So I would suggest, if you want to make best use of automation within Rayyan, perhaps start by screening a bunch of the same papers. There's a paper by Brown et al. From 2000 where they screened 1,250 before using the compute function. So there was a really good bunch of decisions to build those weights that we described before they started using priority screening functions. After that, it's hard to know when you've done enough. A paper by Chai et al. Reports that testing a similar automation tool, they found that about 50% of papers would be a conservative rule of thumb. But essentially, whatever you do, you need to report it. I would suggest that stopping before you've reached a 40% probability of inclusion, so a 2-star rating, would be to willfully miss papers that Rayyan is saying it's not sure about. So I would suggest at a minimum you train the algorithm well by having clear inclusion-exclusion criteria, that pairs of screeners screen a decent number before computing the likelihood that you're going to include a paper and prioritizing screening on that basis. And I would say don't stop before the probability is below 50%. Will you miss papers stopping here? Well, something to remember is that the proportion of studies you miss varies from review to review, and double screening, as it's true of priority screening, that the amount of papers you miss will vary by review. An external test of Rayyan found that between 86% and 99% of papers was found in the first 50%. That's in Olofsson et al. 2016. And that there was hardly any increase in the number of papers retrieved that were relevant by going to 75%. A review by Appengruber et al. In 2022 found that the papers that are missed because they have uninformative titles and abstracts. So it's not inconceivable that single screening everything, but using Rayyan to prioritize your attention for a single screener may even outperform double screening of title and abstracts. So as such, given there are no hard and fast answers in this, I would suggest that whatever you do, just as is the case with every other aspect of your systematic review, be transparent about what you decide to do and follow the PRISMA guidance on reporting it. So in our case, it's item 8 has guidance on the reporting of the use of automation within a systematic review. Now, you might also notice that there are keywords for inclusion and exclusion down the side. These are automatic, and I suspect they are vary by the selection that you make when you set the review up, but I haven't checked. You can define these or delete them. If highlights is toggled on, keywords for inclusion will show up as green text, and keywords for exclude will show up as red text. I know on my screen, the green ones will be black. If you think these are useful, feel free, go ahead and use these, but take care. Remember, not every mention of an RCT is an RCT, and not every mention of a case study is a case study. Lastly, assuming you've signed up from a University of Leeds address, you will see that you have automatic feature extraction. This is where Rayyan's machine learning has tried to extract what it thinks are the population, intervention and comparator merged, although it just says intervention, and outcome is in the paper. I would encourage you to treat this with even more caution than the labels at this stage. But if you have PICO highlighting turn on, these all show up in yellow. And though I understand from the team at Rayyan that these are going to show up in user definable colors at a later date. So don't message me if you find it's a different color when you watch this. Rayyan also allows screeners to label articles, and these labels can be used to indicate a screener's reason for excluding an article, or by selecting a reason from a predefined list, or by creating a new reason. You can even use it to highlight things that you might want to extract during data extraction. But that's not necessary this week, as PRISMA only requires reasons for exclusions following full text retrieval when you've read the full text to assess whether a study is eligible for inclusion. However, given we're in Rayyan now, I will explain how to add this now. My descriptions here follow an excellent guide by some librarians at McGill Library, which I will link to in the description. So, to add a predefined or custom screening decision, select the article being screened. Once the article is displayed in the pane below the listing, select reason in the box above the article abstract. A predefined list of exclusion reasons will appear. Select one of the predefined reasons that applies to your article. However, if none of those are appropriate, you can add your own. For example, you may want to only include systematic reviews, say if you're doing a review of reviews, and mark that the article does not have this study design. To do this, type your reasons in the box, and then Rayyan invites you to add this to the list of exclusion reasons. In this case, the screener does it by clicking the plus, not systematic review, in the box that appears. Your article will then be marked as excluded, and the label with your exclusion reason will be added to the article in red. Any custom exclusion added by a screener is not available, though, to the other screeners in the project. Therefore, you may want to keep in touch with each other or agree in advance what an appropriate wording is for your inclusion-exclusion criteria to avoid problems later. If you want to remove a custom screening decision, you can do that by clicking on the reason box, just as if you were adding a reason for an exclusion. And at this point, you'll see an option in the drop-down list to remove your custom exclusion reason. And you can remove it simply by clicking on it. So whilst you're screening, the decisions are blinded, and the numbers shown will only be for your screening results that you're doing. But when you want to unblind, so you can resolve conflicts, you can use Rayyan in the same way that we used Disputatron last week. And again, we can follow an excellent guide from McGill Library. So when screening has been completed by all screeners, you turn off blinding and resolve the conflict, but only the creator of the review can do that. The blinding status is toggled by navigating through reviews entry in the main review listing, so show all reviews, and then you go back to it, and then clicking on the blind on box, dismiss the warning that appears, and the blinding status will change to blind off. At this point, an email will be sent to all members of the review team advising them of the change in the blinding status. Once blinding is turned off, reviewers can see the articles in which there is disagreement by clicking on conflict in the left-hand panel. Rayyan will then display the conflicting articles on the main screen, making it easy for reviewers to change their response. This allows for rapid identification of articles for which a conflict should be resolved. Rayyan offers an online chat functionality within the screening interface. Access this by clicking on Review Chat on the bottom right-hand corner of the screen. Chat's in real time and allows you to discuss the screening and resolve conflicts. On completion of the initial title and abstract screening process in Rayyan, you may want to export the included decisions into a citation management software like Endnote in our case. and then export them into a new project for Rayyan for full text screening. To export citations selected for inclusion, click on the included decision box on the top left-hand side to filter just the included citations. Click on the export button on the top hand right of the page from the menu and select export filtered only. Choose the desired format. We want Endnote, leave all the checkboxes checked and click on the export button. So what do you need to do after this? Well, next week I'll show you how to use Endnote for retrieving full text. For now, you need to follow the guidance reporting what you've done. Essential elements for systematic reviews, regardless of screening processes used, are that you must report how many reviewers screened each record, so title and abstract, and each report retrieved, whether multiple reviewers worked independently and so were unaware of each other's decisions at each stage of screening or not. For example, where records were screened by one reviewers and exclusions verified by another, and any processes used to resolve disagreements between screeners. For example, did you refer to a third reviewer or did you come to consensus? Essential elements of reporting when using automation tools in the selection process are that you must report how automation tools were integrated into the overall study selection process. For example, whether records were excluded based solely on machine assessment or whether machine assessments were used to double check human decisions. If machine learning algorithms were used to prioritize screening, whereby unscreened records are continually reordered based on the screening decisions, state the software used and provide details of any screening rules applied. For example, screening stopped altogether, leading some reviews to be excluded just based on automated assessment alone, or whether screening switched from double to single once a pre-specified number or proportion of records were eliminated. So, assuming you follow the guidance I've suggested, maybe you'll have double screened, say 1250. From that point, you'll continue to double screen until Rayyan's machine learning system has determined there's a 40% or less probability you'll include the records. And whatever cutoff you decide, be it 40%, be it 20%, be it 5%, you just need to be clear about it. So what do you need to get done this week? The goal for this week is to complete title and abstract screening. And then next week, I'll show you some shortcuts for retrieving full text and completing full text screening. Thanks very much.